Hello, welcome to Science Stream. In today's lesson, we are going to solve two exam questions which relate to sigma notation, which is part of sequences and series. And this is the first question we are going to solve. It says, writing sigma notation 3 plus 6 plus 9 plus 12 plus 15. And from these numbers, you can observe that first of all of them are integers, and then this is just the normal addition. But now, to write it in sigma notation is just a shortened way of writing this beyond summation to just be compact. And to do so, the first thing we need to understand is that these integers in sequences and series, we call them terms. So in this case, we have 1, 2, 3, 4, 5. 5 terms. So we have 5 terms. And you see, each of these terms has its own position. So in this case, if we let R take the position of the terms, or R represent the position of the terms, then we can say the first position, or R1, is 3, because 3 takes on the first position of the terms. Then the second position of R2 is 6, because 6 takes on the second position of the terms. Then you go on 3, where it takes on the third position of the terms, and it's 9. Then we have 12, which takes on the fourth position of the terms, and then we have 15, which takes on the fifth position of the terms. So in short, we have 5 terms. Then from there is something unique about these terms. If you realize one, or if you check one, you realize that if I take this last term, which is 15, I subtract 12, which is the fourth term, and get 3. Then I repeat the same. I take 12, I subtract 9, and get 3 again. And then I take 9, I subtract 6, I also get 3. And then if I take 6, I subtract 3, I still get 3. Meaning 3 looks like a common difference across all these terms. And now that we know 3 is a common difference, we can use it to write these terms in terms of sigma notation. But even something even more interesting is that if you take the position of the terms, for example, 3 was in the first position, and we say, and of course represents the position of the terms. So if I take the position of the term, like for example, 1, and I multiply with the term in that specific position, and for example, in the first position was 3, so I take 3 multiplied by the position which is 1, and get that term. Then if I repeat the same in the second position, which was 6, so I take 2, which is the position, I multiply with a common difference term, which is 3, I get 6, which is the term in the second position. And if I repeat the same with the term in the third position, and the third position, of course, 3, then I multiply the common difference, which is still 3, and get 9, which is the term in the third position. And I repeat the same with 4, so I take 3 multiplied by 4, now there is a common difference, and get 12, which is the term in the fourth position. And then if I take 5, which is the position 5, I multiply with a common difference, and get 15, which is the term in the fifth position. So generally it looks like if I take any of these terms, I multiply with its position, then I get actually that specific term in that position. So now with that knowledge, do we extend the position of each of the terms, multiply with the common difference, then automatically we get the term. So we can put it like this. 3 multiplied by R, where R is the position in the term, and then this in sequences and series, we call it the general term. And now that we have the general term, we can move on to the next step, where we say, of course, we said we have 5 terms. And these 5 terms, we count them from the first one all the way to the fifth one. Where the first one, of course, we got was 3. The second one was, you can even reveal them here. The first one was 3. The second one was 6. The third one was 9. The fourth one 12. And the fifth one 15. So we are counting the 5 terms from 1, of course, the first one all the way to the fifth one. Then from there, the next step is now understanding this symbol here, which we call the sigma notation. And the sigma notation basically means you have certain terms from the first one or wherever they start all the way to the last one. So in our case, we started with the first term all the way to the fifth term. So the first term will come here, or the position of the first term, which now will be r equals to 1 all the way to 5. 5 will come here, then 1 will be here. So it looks like this. We have r from the first term all the way to the fifth term, then summation symbol, which of course we call the sigma notation. Then here we put the general term, which was 3r. So to read this, we can read it like summation from 1 all the way to 5, 3r, where r1 is the first term all the way to the fifth term. You are told to sum them up. Then before summing them up, you need to get the common difference multiplied by the position of that term, which this one we call the general term. So this is the final answer, and that's how we solve that question when we are told to write it in sigma notation. Now, in the second question, I want us to check now one which is written in sigma notation, and then try to write it in the general format. Well, to solve this question 2, we need to borrow the knowledge of question 1. And the first thing we need to understand is how many terms do we have here. As we said, to understand the number of terms we have, we need to check on what starts here, and in our case is 1, and then moves all the way to 5. And then we also need to understand the general term, which is, of course, in our case is 2r. So if I was to read this thing, I would say summation from 1 all the way to 5, then 2r, where 2r is the general term. So now I know this, I can start solving the question. And the first part would be we set it to 1 and then find the general term. I've said it is 2 because it is put here the standard logic of question 1. Then the second step, we need to know the terms run from where up to where. I will say we just identify from here. So our terms run from first term all the way to the fifth term. So r runs from 1 all the way to 5. Then the next step, we need to write now that with each position of each of the terms. So in this case, we have the first term where r is 1, the second term, of course, the position of the second term, third term, fourth term, and fifth term. And then from there, we can now get the terms in each of the position by just simply taking the position of the term, then replacing it in our general term, which was 2r. So at two place we have r, which we say is the position of each of the terms. Now we will be replacing the position. So in this case we have 2, which is this 2 here. Then we multiply by the position of the first term, which is 1, so it becomes 2. So our first term is 2. Then we have r2, which is the second position of the second term, of course, and we have these 2 here, so now it becomes 2 multiplied by 2, which is 4. Is the second term. Then the third term will be, of course, the position, which is 3 multiplied by this 2, now becomes 2 by 3, which is 6. And then we go to the fourth term, where we have 4 multiplied by these 2, of course, which is 8. So our fourth term is 8. And then we go to the fifth term, which is, of course, the position is 5, multiplied by 2, it's 2 here. So 2 by 5 is 10. So our fifth position, our fifth term is 10. Now, we have all the terms. The next thing is to do the summation, as we are told. Yeah, this symbol tells us to do summation. So to do the summation, it's just simple. I'm just going to take all the terms and we add them. So we take 2, which is the first term here. We add 4, which is the second term. We add 6, which is the third term. We add 8, which is the fourth term. And then we add 10, which is the fifth term. So plus 6 is 12. Then 12 plus 8 is 20. Then 20 plus 10 is 30. And that becomes our solution for this question 2. So that's how we solve. Let us meet in the next lesson. Then I'm going to solve other questions relating to other different mathematical concepts. Bye for now.